So, dear students, we discussed about chemical properties of metals, where the metals, when they react with oxygen, they are going to form their oxides, and when they react those oxides with respect to acids and bases, we studied when they react with the metal and acid, they are going to form their respective salt, and water is going to liberate. Okay, hydrogen gas is going to. These are all properties we discussed, and today we are going to discuss another property, that is when metals are reacting with respect to the salt solution of metals. Okay, when they are going to react with the salt solution of other metals, then what are the products they are going to form, and that type of reaction what we used to say. Usually children, when the metal are going to react with the different salt solution of other metal, the salt solution of other metal, they are going to change their ions, they are going to displace it. How we are going to define that? The more reactive element is going to displace less reactive element from the solution. Which solution? Salt solution. So here the more reactive element is going to displace less reactive element to get a different salt, and the product is going to form, that is what? The metal. The general reaction, that is what we used to say, that displacement reaction, that is reaction of metals with the salt solution. Reaction of metals with the salt solution. So here salt solution means what? Salt solution means these are the salt, whereas they doesn't show any acidic or basic nature. These are also known as neutral substance. These are what? Neutral substance. So here the salt solution means except hydrogen, H plus and OH minus. There should not be the substance or compound. It should not have that. It should not have the compound like H plus or OH minus. So here it may be sulfides. Sulfides also salt, carbonates, carbonates and sulfides on phosphate. These are what we used to say that salt solution. So here the reaction of metals with the salt solution, or it can also be known as displacement reaction. Displacement reaction. So what is this displacement reaction? So here the more reactive displacement reaction, how we are going to define? More reactive substance. The more reactive metals can displace, more reactive metal can displace less reactive metal from the salt solution. Less reactive metal from the salt solution. Okay, so we'll discuss how it is going to form. Example. The general equation we write. What is that general equation? More reactive element, that is I am going to consider here metal X. When this metal X react with salt solution, so what type of metal salt solution? What is that? Metal salt solution. Okay, when it is going to react with metal salt solution, what is going to form here? Or you can write that salt solution of metal. Metal salt, instead of writing metal salt solution, we will consider here. Okay, yes, metal I am going to consider as X. Any metal. It is a general formula. Okay, plus salt solution. Salt solution of metal. Why? When these two are react to produce, when these two are react, what is going to form here? Displacing here. Here it is going to form salt solution of metal X. Salt solution of metal, salt solution of metal X, because Y is displaced by X. Y is displaced by X. And what about Y? Is going to form alone metal Y. Okay. So this is what the general formula of when the metals react with the salt solution of metal salt solution. Okay. So look at here. The metal X, when the metal X react to the salt solution of metal Y, the X is replaced by, Y is replaced by X. That is what we used to say, that salt solution of metal X. And here the metal Y is as a ion. It is going to form. Okay, let us take the example here. I am going to consider the metal zinc. When this zinc is going to react with the salt solution of metal. So this is a salt solution of metal. Copper sulfate. I told you what are the salt? Sulfates and phosphates, carbonates. These are salt solution. Any metal with those, any metal carbonates or metal sulfates or metal phosphates, that are what we used to consider salt solution. Okay, even chloride also. For example, NaCl, sodium chloride. Chloride is also salt. And potassium chloride. Okay, calcium chloride. These are chloride and sulfate and one more, that is phosphates. These are considered as a salt solution. So when copper sulfate, Cl, the copper, another metal, 1, and here it is sulfate, salt solution. When it is going to react to form, so here zinc is going to react with sulfate, so therefore copper is replaced by zinc. So ZnSO4 plus copper ion. ZnSO4 plus copper ion. So like that, take another metal. Okay, take another example like iron. Okay, when this iron is react to the copper sulfate. Okay, when this iron react to the copper sulfate. So here the copper is replaced by iron. So therefore FeSO4 plus copper, that is Cu. Then third one, let us consider silver. Okay, I am going to consider silver nitrate with copper. We consider copper metal. Okay, copper, and these all are in solid form. Copper, when it is going to react with AgNO3, silver nitrate. Okay, so this is also salt. I told you except H plus and OH minus, all compounds, sulfates, nitrates, chlorides. Okay, then here the copper is replaced by, silver is replaced by copper. So how we are going to write? Copper nitrate, CuNO3. Okay, so here to balance that equation, we are taking 2 CuNO3 twice plus 2H. Okay, this is what the reaction, displacement reaction. So what happens in this reaction? Whenever the metal reacts with salt solution of other metals, the displacement reaction takes place. So displacement reaction is nothing but the more reactive metal can displace the less reactive metal from the salt solution. Okay, you may ask, how do we come to know that this is more reactive and less reactive? So there is a series is there where these metals are arranged in order by considering the reactivity. By considering the reactivity, that series tells us activity series or reactivity series. So now we will discuss how these metals are arranged. On what basis? I told you some metals are reacting vigorously on the spot. that are sodium, potassium, those are very high reactive metals, right? So on that way they are arranging in a decreasing order, of their activity or reaction with the oxygen, water and metal, acids. On this basis, these are arranged in a decreasing order. Okay, so that order gives to say that activity series or reactivity series. Okay, let us discuss that activity series or reactivity series. How we are going to define that? The metals are arranged in a decreasing order of their reactivity. Okay, arranged in decreasing order of their reactivity. That series of arrangement, that order of arrangement is known as reactivity series or activity series. Okay. Take down here reactivity or activity series of metals. Reactivity or activity series of metals. Reactivity or activity series of metals. So metals can be arranged. How we are going to define? Metals can be arranged. Metals can be arranged in a decreasing order. Arranged in the order of. Arranged in the order of. Arranged in the order of decreasing reactivity. Decreasing reactivity in a series. Decreasing reactivity in a series. Decreasing reactivity in a series. This is called activity or reactivity series. This is called activity or reactivity series. Okay, and some of metal symbols you know, and some of the metal symbols you don't. Here I am going to write in a decreasing order of those metal along with their symbols. Okay, name of the metal and symbol of those metal. Okay, so we will take them here. Okay, metal and symbol. So shall I write this one? Metals, symbols. Okay, so here we are going to write in a decreasing order of the reactivity series. So first, most reactive or more reactive is potassium. Okay, it is potassium. The symbol of potassium is K. The symbol of potassium is K. The next is sodium. The next is sodium. And the symbol Na. Okay, and then calcium. That is Ca. Okay. Magnesium. Magnesium. That is Mg. Magnesium. And then aluminium. Aluminium, Al, okay, then zinc, that is Zn. After zinc, chromium, So here we are considering only selective metals during the exercise. Okay, while we are going to consider examples which is easily understandable up to the atomic number 20 we are considering. Okay, so that's the reason some of the metals not considered for the example. But here I am going to write the decreasing order of their reactivity. That's why consider here these metals. That's after saying chromium that we are going to write as Cr, chromium Cr. Chromium Cr, then iron Fe, then cadmium Cd, cobalt CO. Don't write O as capital, okay? While writing cobalt, C must be capital and O must be small. If you wrote O capital, it means carbon monoxide, okay? Then nickel, that is Ni, okay? And then tin, lead. So here I will follow them again. Metal symbol. Okay. After nickel, the metal is tin. How we are going to write for tin? The symbol of tin is Sn. Okay. Then lead. That is P. So here, on the basis of the hydrogen, these all metals are more reactive than hydrogen. Okay, these all are more reactive than hydrogen, and when they react with acids to give hydrogen, these all metals, when they react with the acid, they give rise to hydrogen. So after here, till here, it is a decreasing order of metals. It's what? Decreasing order of metals. And now will come hydrogen here. Okay. How we are writing hydrogen? H. Okay. And remember children, here tin, lead. These are more reactive than hydrogen. Whenever these metals react with the acid, they are going to give rise hydrogen. Then after hydrogen, what are the less reactive? What are those less reactive metals? Those are less than reactive than hydrogen. So below the why here it is considered the reference. Up to lead, these are more reactive, and after hydrogen, what all the elements are there, those are less reactive. Okay. Yes. First which one will come? Copper, mercury. So here copper, that is Cu, and mercury, Hg. Then after mercury, silver, then gold. Sorry. After silver, platinum. Last gold, because gold is non-reactive with any. So silver, we are going to use symbol Ag. Then platinum, Pt, and gold. These are the symbols of metal. So here, the copper to gold, these metals less reactive than hydrogen, and they do not react with acid to give H2. Okay. So here I am going to write up to from copper to gold metals. These metals are less reactive metals. Less reactive metals than hydrogen. hydrogen. Okay, here I will write less reactive metals than hydrogen, or else you can write than hydrogen. Next, they do not react with acid to give hydrogen. Okay, right. Especially from copper to gold, these metals are very less reactive metals compared to hydrogen. Okay, then from lead till lead, from potassium to till lead. Okay, these metals are more reactive than hydrogen. These metals are more reactive than hydrogen. These metals are more reactive than hydrogen, and they react with acid to give hydrogen. This is what we used to say, that the activity or reactive series of metals. Okay, activity or reactive series of metals. How it is going to be followed? The metals, when they are going to react with the acid, these metals are going to give the hydrogen gas, whereas from copper to gold, the less reactive metals do not react with acid to form a hydrogen. Okay. Till we discuss that, these are what about the metals, chemical properties of metals. When these metals react with the acids, oxygen, water, okay, on that basis we discussed in all the chemical properties how these metals react with the oxygen and what are the products are going to form. When they react with water, what the products are going to form. So on that basis, here these metals are arranged in an order of their reactivity series, that is called activity or reactive series of metals. Okay. Then next we'll move to that, the chemical properties of non-metals. The next concept is what? Chemical properties of non-metals. We know that non-metals are very electronegative because they gain electron from the outer shell to attain or to obtain the noble gas configuration. Okay, whereas all the non-metals, they gain electrons to complete their outermost shell or to get or to obtain a near noble gas configuration. So here, because of that reason, the non-metals are highly electronegative metals. They are highly electronegative metals. Why they are used to call that electronegative metals? Because they gain the electrons from outermost shell. They gain the electron, okay, to complete their electronic configuration, which is near to the noble gas. Okay, so that are called non-metals. And one more, we know that non-metals do not show any lustrous property and they doesn't show any malleable or ductile. Those are what we studied in physical properties of non-metals. Now the chemical properties of non-metals. Chemical properties of non-metals. Chemical properties of non-metals. So here, non-metals are highly electronegative in nature. Write down that non-metals electronegative in nature. Non-metals are highly electronegative in nature. Okay, they have a tendency to gain electrons. They have tendency to gain electrons from. They have tendency to gain electrons in their valence shell. Gain electrons in their valence shell to obtain, where they used to get their dose, to achieve nearest noble gas configuration. To achieve nearest noble gas configuration. Okay. So here almost all non-metals are highly electronegative in nature. The reason behind that is what? They have the tendency to gain the electrons if we are going to combine with any other substance. Okay, for example carbon and oxygen, or else H2O. So this non-metals, oxygen is non-metal. What is that? The oxygen gained the valence electron from hydrogen to complete its shell, to complete its valence shell, to obtain the nearest noble gas configuration. Whatever the non-metals. What are the non-metals? Some more example for non-metals. Almost we are going to consider that 14th group of elements, or 14th group halogen, 13th group. The P block elements. P block elements contain both metals, non-metals and metalloids. Okay. Here the non-metals, usually phosphorus, carbon, sulfur. Okay, these all what we used to say that non-metals. When these non-metals are reactive, they are electronegative. The reason behind, they gain the electrons. They gain the electrons to the valence shell to achieve that nearest gas, noble gas configuration. Okay, in that we discuss that first property or the chemical properties, that when these non-metals react with oxygen, reaction with oxygen. Okay, example, when these non-metals react with oxygen to form oxides, okay, they are going to form the oxides. For example, carbon plus O2, it is going to form its carbon dioxide. Okay, so here during when this carbon is heated, in presence of oxygen, carbon dioxide is going to form. So what it represents? So non-metals react with oxygen. Non-metals react with oxygen where it is formed from the air, okay, to form oxides. And these oxides may be acid or neutral, they never be base, okay, their nature will not be base. So here the non-metals react with oxygen to form oxides, okay, and these oxides may be acid or neutral, but they cannot be, but they never form basin. Exist, okay, but they never form basic oxides. Okay, so here this one property of chemical property of non-metals. When these non-metals react with the oxygen, they are going to form their oxides, whereas these oxides may be acid or neutral, but they never form basic oxides. Okay, so here at this point I am going to end today's class. We'll continue with the next period.